This is section 1.5, which is inverse functions. This also corresponds to the AP standard 2.8, which is inverse functions. So if we're looking at inverses, we remember that inverses are the function reflected over the line y equals x. So if I have something like a parabola, we can think about our line y equals x is going to go right through there. So if I want to do the inverse of that, I would end up with something like that. So what I want you to know is that this right here, while it's the inverse of the blue graph, the inverse in this case is actually not a function because it doesn't pass the vertical line test. So when we're graphing, we keep in mind that we want the inverse to also be a function. So if we took that same graph of a parabola, but we restricted the domain, and said half a parabola, like that, then if we reflect over that y equals x line, then we end up with half of our original, which would be a function. So this is a function. So in some cases, like a parabola where we have y equals x squared, we have to restrict the domain. So if we had y equals x squared, we would say that the domain is where x is greater than or equal to 0, and so that the inverse is a function. There are all other graphs, like if we have that's a weird cubic, but if we have a cubic graph like that, and we're talking about reflecting it over the line y equals x, it's going to end up like this, which is still a function. So some graphs like cubics, we don't have to restrict the domain. Some graphs like parabolas, we do. So down below it says a horizontal line test. So we've talked about the vertical line test tells us if something is a function. The horizontal line test tells us if its inverse will be a function. So if we have something like this type of hyperbola, we would call this 1-to-1. And what that means is if I pass a horizontal line anywhere on my graph, it's only going to touch in one spot. So that means that the inverse is a function. So then over here, if we look at this example, this is another rational function. Okay, so if we had this graph, if I pass a horizontal line right here or up here, you can see that it's hitting in two spots, which means that this is a many-to-one, and therefore the inverse is not a function. And in that case, we're going to have to restrict the domain like we set up above with the parabola. Okay, so the next example is finding inverses algebraically. So the first step might be to write it using y and x instead of f of x. So I can write y equals 5x over x plus 1. So we know with inverses that the x value and the y value are switching places. So I can rewrite this equation as x equals 5y over y plus 1. So that is the inverse equation. And then now I just need to solve for y. So this is one where I have y in two spots, so it makes it a little bit trickier. I'm going to start by multiplying both sides by y plus 1, which is going to give me xy plus x equals 5y, because those are going to cancel. So now I want to get all the y's to the same side. So I am going to subtract the xy to the other side. So now I have x equals 5y minus xy. And in doing this, I now have the y's on the right side together, so I can factor the y out. So I can say x equals y times 5 minus x. So now my last step is I want to get the y by itself, so I'm going to divide by 5 minus x. Oops, 5 minus x. So that would give us, this is our notation for our inverse. The inverse of f of x is equal to x over 5 minus x. That's our final answer. So the last part is not just how do we find the inverse, but how do we take two functions that we know are inverses and verify that they are inverses. So this ties into what we did in our last section where we were doing composition of functions. So if two functions are inverses, then f of g of x will equal g of f of x, and they will both equal x. So we can show using composition of functions that both of them equal x, and therefore they are inverses. So we're going to start with f of g of x. So that means I'm going to take g of x and plug it into the x of f of x. So that would be the cube root of x minus 1 cubed plus 1. So this is, sometimes we want to shortcut and just cross everything off and say, yes, it equals x, but we actually want to show, this is kind of like a proof. So we want to show step at a time what cancels. Oops. So here the cube root and the cube are going to cancel first. So that's going to leave me with x minus 1 plus 1. And then the 1's cancel and I just get x. Then we're going to do the reverse. So g of f of x means I'm going to take x cubed plus 1 and I'm going to put it in for the x. So it's going to be the cube root of x cubed plus 1 minus 1. So now on this one, if I'm taking the steps, the plus 1 minus 1 are going to cancel first. So then I'm going to get the cube root of x cubed, which ends up being x. So that shows that both of these simplified equals x, therefore we verified that they are inverses.